gonna have to mute everybody, but if you do want to say something, just put it into the chat. We've got Shania here as well. I've made Shania a co-host, so she can unmute you if you've got any questions, and we'll unmute you and we can do that. Just worth pointing out as well, we are recording this. Nothing happened before will be on it, but since from the beginning of the presentation, we are going to put it onto YouTube. If you don't want to be on YouTube, just switch off your camera just you can change your name, be anonymous, and we're going to be putting that on YouTube so you can watch it later if you want to re-watch it. Thank you to our sponsors as well, TLA, for again continuous sponsorship. We look forward to seeing you all in person, getting a bit of the pizzas around and a few beers, and seeing some people again after things that died down a little bit with the COVID-19. But it's great seeing some new faces and again some familiar faces there as well. So if you want to as well, we've got a ReSharper giveaway again, another license. Shania, do you want to give some information around that?
Yeah, so basically if you want to join it, the ReSharper license, so basically it's an extension for your Visual Studio. If you want to get involved in that and you're interested in it, then just drop a message in the chat. If you don't know what it is and you want to find out more, just look online about it and then decide if you want to enter or not, because like obviously you don't want to give it to everyone in case someone already has it.
Great stuff. And then other than that as well, I don't think there's much else. We don't need to give any fire exit instructions. We're all good, I think, as long as you all know to check your fire alarms and change your batteries. We're all good. I'll hand you over to John. Thanks, John.
Thank you. You need to enable me for screen sharing. Ooh. Right, can you see guaranteeing application and Azure security with DevSecOps?
Yeah, I can see it.
Okay, full screen, yeah? Cool. Right, thanks everyone for coming today. My name is John Staveley, so I'm a contractor based in Leeds. This is my second talk at .NET Liverpool. My last talk was about messaging last year, or maybe the year before. Some contact details there. So what are we talking about today? So we're talking about DevSecOps and pull left security. So how security fits into DevOps and continuous improvement cycle, and how we can pull security left as much as possible. That is, so at the design stage, at the requirement stage, implementation, testing, and deployment to production. How we're going to amplify security feedback, so get as much security feedback from the application and the platform as possible and feed that back into requirements, so we're continuously improving security. We're going to work with enhancing an overall security baseline and work with secure by default. So take a sample project that has a lot of security work done on it. That should improve our security footprint. We're going to be looking at reproducible deployments using Azure Devops. So these all have all the security features built in. So it's testing the security at every phase and providing that security feedback. We're going to be doing that using Azure pipelines and deploying a platform using on templates, which is the Azure Resource Manager templates. So how you pull security left as much as possible, there's a load of tooling, and the tooling can be done on a developer workstation for the most part, but also in the as part of the build pipeline. So checking whether the developer has bothered to check or not. So we're going to be doing some lightweight threat modeling, emphasis on the lightweight, some checks in the IDE, doing some static analysis on the code, the platform, in this case, that's Azure, the components, so NuGet packages, JavaScript libraries, that kind of thing. Reinforcing our security profile using security unit tests, and then do some dynamic analysis. So that's something called OWASP ZAP. So it's kind of like a mini pen test. And then again, doing some testing by acceptance testing this time using Selenium. This is a whistle-stop tour, so I don't expect you to remember everything or make lots of notes, but all of the code is on GitHub, which you're welcome to steal, and the slides will be on SlideShare. So we'll get that distributed at the end. So why should we bother with security? Well, EasyJet got hacked less than a month ago. It looks like the fine they'll be getting will be in the order of hundreds of millions of pounds. British Airways and Marriott were also fined, hundreds of millions of pounds for letting customer details out. And then there's an enormous, huge list. In fact, Facebook, Instagram, Connecticut patients, hospitals, banks, retail, you name it, they've been hacked. The bigger you are, the more likely you are to be hacked. But also there's a lot of automated tools that just go from site to site looking for vulnerabilities. So even if you're a small company, there's automated tools looking for and probing for weaknesses in your infrastructure. And with the general data protection regulations in the EU, there are enormous fines that can be levied against organizations for not having a secure platform. So DevSecOps is just DevOps with a bit of a focus on security. It's a bit of a buzzword, but it's kind of a nice word that describes what we're going to do today. So DevOps encapsulates a process that enables a fast flow of work from dev to operation. So we're pushing deployments out to production on a rapid basis. The DevSecOps part of it, we're getting security and amplifying that back. So we're feeding that back into the requirements and using monitoring and logging to gain security feedback, and also what we get free with the platform. And we're constantly improving our daily security work and our security knowledge. And we're working with secure by default code and platform. So I've got an example project and an example platform, which has been pen test, put through the ringer. It's been worked over a long time. Is secure by, has a lot of good security features in it. So what do I mean by pull left? So pull left is earlier in the development cycle. So here's a typical waterfall process where you've got requirements, design, 6 months of coding, 3 months of testing, redoing all the bits you missed, and then hardening and production. And that doesn't work with our iterative way of producing requirements these days. However, security is still left to the end. So you may do like 6 sprints, but then you're ready to release something to customers. And then someone goes, oh, well, maybe we should do a pen test. And fitting security in right at the end there is still a very waterfall way of doing things. What we want is pulling security in at every stage, at design, at coding, at testing, and hardening, and also getting feedback from production into requirements about what we can do to improve our security, and not leaving it to sprint 7. So what are the benefits of this? Secure defaults means fewer security defects. If you're taking a project that has already had a security analysis done on it, it's less likely to have security issues. DevSecOps means you've got a reduced average time to detect a security issue because of the feedback from production. Automation, the fast flow from dev to ops, you're pushing your releases out means you can deploy security updates quicker. So if a 0-day attack drops, you can then get a fix in and push it out to production very quickly. Lots of changes, and a platform that's changing constantly provides a moving target to hackers, and research has shown that it's more difficult for them to gain a foothold in your system if the system's constantly changing. And of course, fixing production is 6 times more expensive than fixing the design, and that applies for security as well. So we want to find out security flaws in our application sooner rather than later. So what are we going to secure? So three or 4 years ago, I came up with the Security Essentials project. It's kind of like file new project, MVC application, but with a load of security features. So it's exactly like a plain vanilla, untouched MVC project, but with the OWASP top 10 enforced in it. So it uses an object relational mapper to defeat SQL injection. It's got a strong account management process. It checks against Troy Hunt's cloned passwords. It uses a strong hashing algorithm and a strong encryption algorithm. Uses and enforces SSL. It's got all the correct security headers that you expect to see a web application. It defends against cross-site scripting. It encodes all the output, not just the standard output, which you get for HTML. Defeats insecure direct object references, enforces authorization, conceals errors and trace, lots and lots of security features. It was written in .NET, so I appreciate a lot of people on .NET Core these days. The fact it's .NET is not really relevant for this talk. I just needed a sample application which I could then deploy. But I just wanted to make you aware that there's an application there that is useful for retrofitting security into a .NET application. So in terms of the platform it's going to sit on, so this is more about the talks about, we're going to take the application, deploy it onto something, and then get the security feedback. It's a web application, and then I use Cloudflare, which is sort of the best of breed firewall to defend it from your nefarious user and also help your paying customer. You've got an app service, which is a website sitting behind that. The app service is locked just to talk to the firewall and nothing else. Then you've got a key vault for storing secrets, a SQL Azure database, and blob storage. So it's a very standard website that security has been enforced in each of these different resources. So the demo code's there, so you can go and you can steal that. So that has the application code, the ARM template, the deployment scripts, the Azure Devops pipeline, so it means to deploy the application as well. We're using infrastructure as code, so we can get repeatable deployments, and that's all done using an ARM template. Cloudflare set up using PowerShell, and Cloudflare forces TLS or SSL, as some people know it, HTTP2, enables the web application firewall for defending against SQL injection attacks, cross-site scripting attacks, cross-site request forgeries, that kind of thing, protects against denial of service, and many, many other threats. So it's a best of breed firewall, web application firewall rather. But then app service is locked down that we talked to Cloudflare, Azure Key Vault, protect secrets, virtual net, all of the assets, the resources are sitting on a virtual secure network. That includes the blob storage. Blob storage enforces encryption at rest, in transit, and it's firewalled to the virtual network. So if you create a new resource in Azure, it won't have all of these security features enabled, but I've been through the process to create them and to get validation that they're working correctly. So the SQL Azure database enforces transparent data encryption, gives you periodic vulnerability scans to get that feedback to you that your security is working, and enforces backups. Not that one. Right, so I'm just going to talk you through Azure. I kind of assumed that people are familiar with cloud. Most people use AWS or Azure. So I'm just going to show you the assets that are deployed here. So this is what it looks like when it's deployed. So you've got application insights for logging, network, a database, a server and a database, some blob storage, an app service, and then security for the network group. And availability test will just keep pinging the website to make sure it's up. So some of the things that you configure through the ARM template, security settings. So if you go into the configuration there, it has things like, FTP is switched off. Microsoft have made the mistake over the years of having things defaulted on. So some of the security things you have to do is for instance, disable FTP and disable WebSocket. So you haven't got that increased attack surface. So how do we get that? So what we do is we use an ARM template. So if you go into Visual Studio, you've got a nice JSON editor here, and on the left you've got a list of resources, variables and parameters. So you can parameterize this for different environments. So an integration environment, a live environment, a QA environment, and different variables and settings for each of those. So here's the resources that you saw in the Azure portal. The JSON editor is a bit slow, probably because it's loading all of these lovely graphics for you. So if I take the app service that I showed you there, we can see that we define the FTP state to be disabled by setting that property. And then there's other sections to attach that to a virtual network, to do configuration settings for the web.config file. So you take this massive JSON file, throw it at Azure, and it sets up all of those web services that you saw in the portal. So why automate? Well, automation is great because we can create new environments. So say the boss turns around tomorrow and goes, well, we need an environment where we can have some pen testers in, and they're going to hammer the website, and we want to give them free rein to do that. Well, we can set up an environment to do that because we just set up a new set of parameters for a security environment. We bring it up, deploy our code to it, and then once they've finished doing their pen testing and investigation, we can just destroy that environment. You want an environment for doing performance testing, for hammering it against resilience for denial of service attacks. You can bring it up at full production capacity and then crash it down 2 hours later. You can also roll forward. So if there's any security vulnerabilities that you discover, you can fix it in code and deploy quickly. So continuous integration, continuous deployment is like your heart of security. It enforces the rules, it enforces, as you've seen, the state of the platform. So if someone goes in and makes a minor change, that ARM template, which is fully audited, will then reinforce the security of your platform when you next redeploy. That's all audited. So the ARM, any check-ins which disable security features will be audited with someone's name against it. So you can guarantee the security of the application. Right. So we need to deploy this. So I use Azure Devops. So just going to click in here. That's what I was logged in. So this is your ARM, your Azure pipelines. It's a YAML file, so it's basically it's all indented with white space, which is quite difficult to work with, but you kind of get used to it. Decided to go tonight. I was logged in earlier, come on. It's more usually the beginning of this template. Oh, it's saying my internet connection is unstable. I hope that doesn't mean that it's going to log me out. So you set up some variables. And you've got 3 different stages: build and unit tests, and then deployment, and then running OWASP SAP. So you get all of these different sections here. So say I wanted to put in an OWASP ZAP, OWASP dependency check, for instance. I would put in all these variables and then do add, and it would create that section for me. And that's the easiest way of creating a build task. So here I've got SonarCloud prepare, NuGet install, and NuGet command, and then build, and a lot of standard stuff you'd see. So the Azure Pipelines enforces the security checks. And so it does the deployment, does the build, and does the security checks, and enforces security at each of the different build stages. So for a lot of the security features I'm going to talk about, you need the marketplace quite a lot. So all of these, well, a great deal of these extensions are free. So if I wanted to, for instance, search for any OWASP extensions, I would just go in and take, OWASP dependency checker, and then I'd click that, and then it would add it to my subscription, and then I can add the OWASP dependency check task as it appeared there, and that would then populate my Azure pipelines. So a lot of the security checks I'm going to talk about tonight require the marketplace. Okay. Let's hope it's not slow. Yeah, don't let me go back on it. No, I don't need to do that. Right. Okay. So the Azure pipelines requires lots of variables, and that's where you keep your secrets. So don't do what I did and quickly flicked on my secret variables onto screen while I was being recorded, because it was on fractions of a second, but it was still long enough for one of my colleagues to point out that I'd put the company's secrets on the screen and it'd been recorded. So I had to change things. But I'm not going to do that tonight because we've got this variables section here. So here it's all hashed out, so you can't see. So there's important secrets there which are deployed as part of Azure pipelines build and injected into PowerShell commands. Okay.
John, can I ask a quick question?
Yeah.
With them variables, are they stored in the repo?
No, so they're stored in Azure Devops.
DevOps, brilliant, thank you.
Because you should never store secrets in your repo.
No, just checking.
Yeah. Okay, so this is what my Azure pipelines looks like when it's set out a bit more clearly. So the first stage is build unit tests, second stage is acceptance tests. So it does all these standard stuff, NuGet, npm restore, build and package, then enforces security unit tests, and then does some static code analysis, component analysis, checking of the platform, anti-malware scanner, credential scanner to work out that you shouldn't have checked in those credentials, and then publish the artifacts so they can be deployed to later environments. So once it's gone through all those quick checks, and they take about 4 minutes 15 to run, it then sets up the paths. So all of that ARM template it sets up in Azure. It configures the firewall, and it does that through a series of PowerShell scripts and Cloudflare's API. It then deploys your code to the integration to the server, runs security acceptance tests against them, and then does dynamic analysis. And also, it can then tear down the paths as well, so it can delete all of those resources if you no longer need them. So how are we going to pull security left? That is enforce security early in the development cycle. So a diagram I quite like, which I've stolen from a book I'm going to recommend at the end, is this one here. So let's say that Josh gets some requirements changes and a request to change some code. So he starts thinking about making changes, and then he makes changes. So at this point in time, he can do threat modeling and do some IDE checks and get his colleagues to peer review the code that he's checking in. He then commits it into a source code repo. Then it gets built, and the time it gets built, it can use the Azure pipelines build scripts, and it can enforce software component analysis, static analysis, and do security tests. Then you've got the binaries. So it's build and deployed a package, which is then deployable to live. At this stage, you can do dynamic scans using, for instance, OWASP ZAP, and then you do your automated security checks because it's deployed against an environment. So finally, it gets deployed to production, and then you monitor that for security and get feedback from the platform on your security profile. So that's what we're going to look at. A little bit of lightweight threat modeling, IDE checks, component analysis, all of these things. So first stage we look at is the pre-commit stage. So look at some IDE checks and threat modeling. So lightweight threat modeling. So the emphasis is on lightweight here. I've read various articles on the web and they go, convene a team for a minimum of 90 minutes. I probably wouldn't do that. That's way overkill for this. So what do we mean by threat modeling? When the code is the design, where and how do you catch security problems in the design? So the only way you can do it is if you design it somewhere and then it feeds back to you that there might be some problems in the design and there might be some threats you need to consider. So the threats we consider are understood by this STRIDE algorithm acronym. So spoofing, that's pretending to be someone or something you're not, as you get if, for instance, if you had a cross-site request forgery attack. Tampering of data, sniffing or changing something at rest in memory or in transit. So for instance, if an example of that is a SQL injection attack. Repudiation, doing something and then denying you did it. That would be supported by weak logging. If someone on an IP address in your company did a credential stuffing attack on your application, but your application wasn't logging the fact that there was a failed login attempt, then they could repudiate that they'd actually tried to hack your system. Information disclosure, giving information to an unauthorized person. So that's if like your error messages are displayed on the screen or you get a man in the middle attack. You're allowing man in the middle attack by not having encryption end to end. Denial of service, so degrading or preventing access to service. So there's pounding the web application with lots of requests. That's classic denial of service, but also locking out accounts. That's another example. If your application is beyond use, then that's denial of service. Elevation of privilege, doing something you're not authorized to do, i.e. via an indirect object reference. So you just change your URL slightly and you get to someone else's account details and it's not checking that you should be there. So Microsoft have produced this brilliant tool called the Microsoft Threat Modeling Tool, which you can get from that URL. And it comes with an Azure template. So it gives you all of those threats for classic resources that we'd use in Azure and tells you how you need to go about security and the kind of different threats you need to consider and the mitigations you can take. Okay, so this is the threat modeling tool. So here we can see our nefarious actor called user interacting with the browser, coming through the Cloudflare firewall, and then there's it talks to the app service, and then the app service talks to blob storage, SQL database, and the key vault. So between all of these are modeled the different interactions. So here you can see there's an HTTPS request going between the firewall and the app service. Here you can see there's a TCP request going between the app service and the SQL database. And seriously, this took about an hour to throw together. It's really very simple. So you should do this often, but not a lot of it. So when you're adding a new resource into your application, when something's changing, like you're opening a port or as a new means of conveying, talking between the applications, then think about doing threat modeling. So I take assets from here, like I could drag on Azure Cosmos DB and then take a request and response between the two to show that the app service is talking to Azure DB, and that's how you model it. And then it gives you this analysis view here. So here it looks at all the different interactions and says using STRIDE, there is potential denial of service here between Cloudflare and the app service. An adversary may block access to the application or API hosted on Azure App Service through a denial of service attack. That's denial of service. Possible mitigations. network level, blah, blah, blah. So it tells you what you need to do there. There's links you can go to. So I've said that this is mitigated. So I put it as status mitigated. And my justification is that Cloudflare correctly configured will block a denial of service attack. So I'm saying that that threat's not there because of the way we've got the resources set up together. So this another one is an information disclosure. You see, as I click on these things, it's highlighted in the diagram. Again, this is between Cloudflare and the app service. So it's saying there's a information disclosure risk. I've judged this to be mitigated. An adversary can fingerprint an Azure web application or API by leveraging server header information. So the Security Essentials projects removes the server headers that go out that says, yeah, I'm made by MSC, yeah, I'm made by Microsoft. And that's what it tells you here. So this link here, which is standard, it tells you which headers to remove. So I can say, well, that information disclosure risk is mitigated. So again, between the app service and the SQL database, there's an information disclosure privilege. And an adversary can read confidential data due to weak connection string configuration. Possible mitigations, ensure encrypt equals true and trust service certificate equals false are set. So I've said that's mitigated, and justification is I've done what they've asked me to do. So let's say we've got a developer and they're practicing CV development, and they go, oh, yeah, I like Azure Redis Cache. I'll have one of those. That looks quite good. So I'll just very quickly model that. So I want my app service to talk to the Redis cache, and this is going to talk back. So make requests to and from. So you can see that I'm considering using Redis cache, and it's taken me seconds to set it up. Now you see at the bottom here, there are some new threats. So there is an information disclosure risk between the app service and Redis cache. An adversary can read sensitive data by sniffing traffic to Azure Redis cache. And there's the mitigation. So I can choose to implement mitigation by ensuring Azure is talking over SSL. And then I can mark that as mitigated. So I've come in, I don't know anything about Redis cache. I've never used it before, but already I know something useful about how to mitigate the threats against it. Okay, so now I'm going to talk about IDE checks. So this is in Visual Studio or some other IDE. And in the IDE, the different plugins that you can get for Visual Studio, would like them to check some basic security headers, something like SQL injection, weak cryptography, packages used. So all of them should have IDE integration, obviously. Most of them would also run in Azure Devops. So if the developer chose to ignore the advice, it would when they check in, it would get fed back to them, and maybe also fail the build if you wanted your rules to run that way. A good package would allow building of your own rules, and a lot of them do. It should have a low false positive rate, and links to code examples and tutorials if you want examples of best practice. So the developer can go in and be very productive and fix the security flaw quickly. And also very able to define exclusions. If it's a false positive, you don't want to be reminded of the fact it's a false positive repeatedly. Oh. Okay. Right, so the checks that I've looked at so far, you've got DevSkim, which can find insecure hash encryption algorithms, URLs. You can check for some credentials in code. PumaScan has got free and pro versions. It can check for secrets, look at compiler settings and authentication settings. VeraCode was a bit tricky to set up. It needs an account. It can do a lot more and look for SQL injection vulnerabilities. And there's also the continuous delivery tools for Visual Studio by Microsoft DevLabs. So that can do all your credential scanning locally. So I'd say this is very much the thin end of the wedge in terms of IDE checks. It doesn't test for a lot of things, and you know, you do get some false positives. So for instance, I'm glad I didn't use MD5 here. Right, so I'm saying that I in a text file I didn't use MD5, but I'm getting a red squiggly that says this is a weak or broken hash algorithm, and it's going to remind me of that every time I get into this file. So even though it's a text file, it's not actually that useful. So it does help you with some things, but there's a lot more coming later that is a lot more useful. Right, so on to continuous integration. So my code's been checked in now, and we're going to look at static and application security testing and component analysis and unit tests. Okay, so for this, we're going to look at FXCOP, which has a nice security plugin. There are others. So with all of these things, there are always competitors. There are lots of things in the marketplace which do the same thing. I'm proposing, you know, a selection of them to you as an example of each type of check at each stage. So for FXCOP, the static analysis, there's also Puma Scan and Roslyn check. So Roslyn checks take a bit of configuration to get in. So there's SonarCloud, which is SonarCube as a service, which is pretty cool service, and you know, does all that static analysis, gives you code examples when things are wrong, which is we're showing you. And then you've got a package that Microsoft have bundled together called Microsoft Security Code Analysis. So for static checking, we're looking at Credential Scanner, Roslyn Analyzers, and TS-Lint. And then there's the ARM template checker. So this is checking an ARM template to say whether it has a really good security profile or not. So the ARM template being was the thing that set up the resources I showed you before. So FXCOP, it checks a great number of things: code quality, design flaws, globalization rules, naming, performance, maintainability, portability, reliability, and of course, security. So security is what we're interested in. It can catch insecure SQL, weak class design, insecure XML and DTD processing, which is in the OWASP Top 10 2017. Can tell you if there's an anti-forgery check missing, if you're using weak cryptography and hashing, and whether you're using deprecated security protocols, and lots more. So it does that all in the IDE. So it's kind of like an IDE add-in, but it's a lot more. It does a lot more in-depth checking than just pattern matching on saying MD5, for instance. So you get it in by doing install package FXCOP analyzers. So this package is marked for development purposes. So it won't, if you build it, it won't get deployed with your application. It's just there at build time to run against the code. And also you need a version which matches your build agent. Otherwise you just get a load of errors when you deploy it in something I've had a problem with. Right, so this is my Security Essentials project, and I'm going to go to the packages, and I'm going to go to Microsoft.codeanalysis.FXCOP analyzers, rule sets. So here I'm grabbing the rule set, security rules enabled, just copy that and paste that into the application here. So if I click here, you can see there's all of the things it checks for, presented in an XML form. So for instance, you can check for LDAP injection, and you can change that to say go from a warning to an error. So if you get as an error, it's going to fail the build, and you won't be able to get it through the build pipeline. Depending on how you want to approach dealing with the security vulnerabilities. So the other thing you have to do, as well as copying in the rule set, is you just unload the project here. You put in this segment here. So code analysis rule set, and it says check these rules basically. Right, so here I've got my hash algorithm. So I'm using secure hash, but let's say I don't use secure hash. I'm using the rather rubbish SHA-1. So here immediately I'm getting some squigglies that say you're using a weak cryptographic algorithm. So you know that at design time, and then it shows you potential potential fixes. So you can change your code back to using SHA-256. So again, that's enforced at build time in the build pipeline, and you can go to that particular rule and say, if they use SHA-1 in the application, then fail the build. So next we're looking at SonarCloud. So SonarCloud is SonarCube as a service. It's got a website there. So you basically, if you're using the free account as I am, you push the code to there, which is now publicly available. I'm happy about that because yeah, it's an open source project. But you can get a paying account, and then all of that analysis gets closed off, so only you can see it. So it shows you what is wrong and how to put it right, bugs, security vulnerabilities, invalid CSS, deprecated HTML, performance issues, code duplication, and of course, security. Free for open source projects. Analyzes where bugs are clustered. So if you've got Kevin, dodgy coder, on your team, you might find out that yeah, there's more bugs clustered around his application, or Friday afternoon is a really bad time for checking in code. So it does all that kind of analysis on your build. You can also set it to fail the build using the Azure Pipelines step. So we'll have got the SonarCloud add-in from the marketplace. So here's my Azure Pipelines checked in with the code. So it's just part of the build steps. So you have to put in this SonarCloud prepare, put in my organization name and the project key I got when I set up the account and the project name. So that sets it up. Then it analyzes the code. So that takes all your code, pushes it up to SonarCloud, does all the analysis of it, and then it publishes the results. They become an asset in the resource, so you can check and later build yeah, what your bug profile looks between check-ins. So this is the Security Essentials project in SonarCloud. So I can see that I've got 38 bugs, 1 vulnerability, 87 security hotspots for an allegedly secure package. So that's quite interesting. 568 code smells. I really didn't realize my code was that smelly. But that's quite interesting. Let's have a look at the vulnerability. It's saying in account controller, refactor this code to not perform redirects based on tainted user control data. So if I click on why is this an issue, it'll give me some information about yeah, what the threat is. And this is going into the code itself, and it's saying log on async, you take this parameter return URL, which is passed to this function here. In this function here, you return based on that data. So at no point do you check the data. So this potentially could redirect me to an evil website where I can grab the fake my login page again and grab their user details whilst then redirecting me to the original website. So it steps you through why this is a vulnerability and tells you what you need to do to fix it, which I think is pretty cool. So Microsoft have come out with this Microsoft Security Credential Scanner. So it detects credentials, secrets, certificates, and other sensitive content in your source code and your build output, because you should never check in secrets into your source code. So it includes 25 searches and supporting 70 or more file types. So in my build pipeline, the MCSA steps look like this. So this is just one of them, the credential scanner. All of this is fast feedback, I have to say. So the entire, even with all these security steps enabled, you know, the whole build cycle is still under 10 minutes. So it's fast feedback to the developer. So what it does is it gives you a file that looks like this here, and it says there's a file called web.live.config. There's a secret in the file, and maybe you want to do. So it's found the password or symmetric key. And then there's a number of another here that it's found. And again, yeah, so the MCSA, you can produce a report that formats the XML file nicely, and then also the decision whether to break the build on it as well. So if someone checks in a password, you can fail the build. That's your choice. So in terms of static checking, it's got TS-lint. So this checks TypeScript code for readability, maintainability, and errors in functionality. Its security rules include, you know, banning eval as evil. We don't want that in our code, thank you. There's some terms and conditions using no string-based timeout. I don't know why that's an issue. Use string is obviously good practice, so you can check that in part of your build pipeline. Roslyn analyzes, it's a bit tricky to get set up, but it's kind of like FXCOP. It integrates with your code and then performs static analysis on your code, particularly more appropriate if you're using .NET Core. And again, produce an output and can break the build if required. So to get this, everything I've looked at so far is free. Some of the dev add-ins, they've got paying versions and free versions. This is actually quite expensive, but it comes with a number of packages. And you need an advanced tier or above, or pay between £5,000 and £7,500 per organization. So in Azure DevOps, an organization can have thousands of build pipelines. So I think this is more for sort of a large organization rather than a small one. So we now look at static checking using the Azure Security Toolkit. It's a really good package. I've only used it again. It can run security checks against resource group, ARM template, and Azure subscription. So I only used that for those three, but it can also set up continuous assurance steps and set up monitoring and telemetry. So don't ask me about those two. I've not used them, but the first three I have used. So it's constantly updated. Like a lot of these tools, when you run them, it goes to a server and it says, have you got any more rules? Because security is a very dynamic, moving place. You don't want your security checks to be stuck in 2012. You want all the rules up to date. So there's a README on that site. So the first thing you can do, you can check resource group or ARM template, pretty much for the same steps. So it checks obvious things like HTTPS only, HTTP2, roles are configured, TLS bindings are configured, WebSockets disabled, FTP disabled, backups configured, ordering and monitoring configured, cores not overly permissive, etc. And then blob storage, locking down to virtual network, HTTPS access, etc., etc. So for each of those resources that you've got deployed, it'll go, well, what's best practice and what's in the ARM template, what have they got configured, or what have they got deployed? So it's just a simple matter of doing install module AZSK. I'm not going to do that now because Microsoft has this habit of changing PowerShell modules very rapidly, and that's caused me some upset doing a demo when it broke my demo. So here I'm saying get the AZSK ARM template check security status. So it's taking that ARM template that I showed you earlier, and it's taking the live parameters for that file, and it's saying ignore these checks here. Right, so it ran very quickly there. And it showed you, yeah, failed, 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 passed, passed, passed. And then it created this nice file here. So it's saying for the SQL Server, there is a test that's failed. It's high priority. So for the ARM template, it expected to find administrator type and allow Active Directory, which it didn't. So Microsoft says, this is good practice. This is what you've got. So there's a difference between the two. Here's another one. So for let's do another one for app service. So for the app service, it's failed, and it was expecting site config, site auth enabled to be true. I don't know why that's an issue. Okay. And then here's one you got marked as verified. So verify that you want the deletion retention policy. So it's a lot of good practice. It runs it and it says, well, it's passed all of these. It checks, WebSockets are switched off, always on is enabled for the availability, remote bugging is disabled, request tracing is enabled, all of these kind of things you'd expect to be good practice. Now you might decide that I don't like administrator type Active Directory, so you can define an exclusion file. So you basically take a subset of these as failed, and then run that and then define it when skip controls from file. So you define it in the CSV file. So here it is in the Azure pipeline. So it's pretty much the same thing. So there's my ARM template, there's the parameters, and there's my exclude. So again, it's developer can do self-service and get those security checks locally, but they can also do it in Azure. You can also run it against, I'm not going to do it here, but you can run it against a resource group. So this is against deployed assets, and it's got this flag generate fixed script. So for instance, if it'll give you a PowerShell you can run against your Azure platform to implement some of the security fixes I've just shown you. Okay, so now we're going to move on to software component analysis. So we're looking at OWASP dependency checker, white source bolt, and then look at the MSCA packages, anti-malware scanner, and bin skim. So the OWASP dependency checker is published by OWASP, the Open Web Application Security Project. It is free. It checks the vulnerabilities from the National Vulnerability Database, or NIST. So it checks for things like cross-site request forgery, cross-site scripting, denial of service, remote code execution, buffer overflow, if that's appropriate, and things like that. It can generate false positives, as I'll demonstrate. So it needs some manual checking and maybe an exclusion file, which I'll demonstrate how to produce. So here I ran it earlier. So when you download it, you just take it, copy it to a directory. You run this bat file. You say scan this directory. This is my suppression file here of this project, and create the port here. So every time you run it, it checks for updates because, again, you know, vulnerabilities are coming out all the time, and then downloads the latest updates. So these are all of its scanners. So it's got things that you expect to see like retire.js, checking for redundant JavaScript libraries, MS build, NuGet packages that have known vulnerabilities, that kind of thing. So I know it's found a few there. So it produces this report, which is quite nice. Right, so we have a look at this one. So it's saying that there's a high severity vulnerability with compiler services.unsafe 7.1. It's highly confident that it's identified the right package via 4 pieces of evidence. So if I click into that, it's saying at this location here, it's used these identifiers. So the evidence, so I thought it would do something like match it on a hash, but it can't do that because it lives in a world where some people compile their own NuGet packages and JavaScript files, so it uses a different method of identification. So it's saying, well, the vendor's right, the product's right, and the version's right. I'm pretty confident this is the package that has the vulnerability against it. And it has a CVE code, the common vulnerability exception. The user resource create function in services module, blah, blah, blah. For Drupal, uses a password of 1 and create new accounts. Well, okay, so what it's saying is this library here was used in a version of Drupal which had a vulnerability identified against it. So that I'm confident that I'm not running Drupal, so I can copy this into my suppression file. So I can grab this XML snippet here. And this is the suppression file that lives in my project. So these are the ones I'm suppressing at the moment, because this CVE code, for instance, is not applicable to me. So here we're going to look at another one, .NET Core Analyzers. It's very confident, lots of confidence it's found the right thing, it's matching the right thing. It's saying, a remote code execution vulnerability exists in .NET software when the software fails to check the source makeup of a file. Okay, so I'm not sure that this one doesn't apply to me. So now I need to take this away and do something about it. Either decide that I need to mitigate it in some way, by banning certain kinds of file from my application, or I need to understand more about the vulnerability. And again, the OWASP dependency checker, it can be run locally, it can be run on the build server, and you can get it to fail the build. If, for instance, all of these have, let's have a look. It's meant to be a score. There's a CVSS code which I can't find. Okay, right, so this one's high. So you can fail the build if, for instance, the CVSS code is above a certain level. It's between 1 and 10. So we think anything above 2 needs to fail the build. We need to, and it wants to be a 10 before we start thinking about failing the build, that kind of thing. Okay, so white source bolt, this show, it does a similar job. It shows NuGet package and npm package vulnerabilities. It also shows license risks and compliance. It's got free or paid versions. So the free version's got 6 or 8 languages it covers. So one of those is C#, another one is JavaScript. So 2 very common ones. And then the paying version's got 60 or 80 languages, something like that. So to set it up in your build pipeline, it's very simple, a few lines of code. And then once it's run, just build. Right, so it gives you this nice diagram, and it says, for instance, security vulnerabilities, jQuery before 3.0 is vulnerable to cross-site scripting attacks, blah, blah. Okay, so, oh yes, so it's that data grid I'm using. That does use jQuery 1.9.1. Okay, so we've got a cross-site scripting vulnerability in the application. Maybe we need to upgrade the data grid. So you can make a pitch to the management to buy the latest whiz-bang Ajax JavaScript library that you like, because it's got a vulnerability with it. It gives you this nice graphic, 2 medium vulnerabilities associated with it, and it goes to license risk as well. So it's saying one of the libraries you're using is GPL. That means all the rest of your software is GPL. Possibly you don't want that, you know, if you're like running for a private company. I'm not a open source, so I don't particularly care, but it might be important to some people. So it rates all of those license risks. So with all of the checks we've done so far, looking at the libraries and the packages we've imported, a developer can still check in something that's malware and allow us to download. To check against malware, there's the MSCA anti-malware package. So you can use it using Azure DevOps and a Windows build agent in Azure DevOps, but it requires Windows Defender if you're on a self-hosted agent. So you can't do this on Linux, for instance. Then finally, you've got bin skin. So it looks for outdated compiler settings, ensures most secure compiler settings are used, and if they are signed, that the binary is using a strong crypt algorithm. So this isn't really for web applications. This is more for applications where you deploy them to a phone or a laptop or a tablet like that, where they could potentially get access to those libraries. And you want to make sure that your application you wrote only communicates with libraries that it's meant to, and it will do that by strong signing. So it's possible to do security unit tests. So the ones that I've got in the Security Essentials project check for that the hashing and encryption algorithms work, is use PVK DF2 and SHA-512 encryption algorithms. So I just check that I can get information in and out of that in the right way. I can check that the email templates I send out contain the phishing warning. The account creation and password research process is very well enforced. So companies like Netflix, you know, what they do is they hash important code like authentication and finance. And if the code checked in doesn't match what they hashed, then it will email security and say this test has failed. Someone's changed the auth code and it wasn't authorized. So that's another example of a security unit test you can have. So this unit test here, as an example, this checks that the authentication is applied to the controller. So it does this by reflection. It says, so I put this typically against all my controllers. So get the custom attributes and check if there is authorized attribute. And then for this one, that there is a role of admin assigned to it. So if someone removes the authorized attribute or changes the roles that are permissible on that, then it will be a test fail. So this one, all HTTP state changing control actions should be decorated with a validate anti-forgery token, so we can defeat cross-site request forgery. So HTTP web post put delete, post put delete, you should expect there to be a decoration of validate anti-forgery token. So if you forget to put it on, which I frequently do, it will fail the unit test. Okay, so we've checked in code, it's in repo, it's been built, it's in binary repo now, and now it's going to look at deployment and acceptance tests. So we're going to look at a couple of security checks you can do here, dynamic scans and security acceptance tests. So you've seen Azure pipelines. Very quickly. So after it gets through the first stage of checks, it then deploys as a stage called deploy integration, downloads the artifacts. This configures Cloudflare, and then this deploys the ARM template. that deploys the website to the app service, and that puts in some more security. It binds the app service to Cloudflare, for instance, and then this configures the acceptance tests. What to say about Cloudflare? So this sets up the assets in the key vault, and then this Cloudflare's got a REST API. So this is just all this is doing, interacting with that REST API, and it's saying in Cloudflare, set always use HTTPS is on, minimum TLS version is 1.2, TLS is on, SSL is full. So your standard security settings. And if you're not on the free version of Cloudflare, then turn the WAF on. So that's the thing that blocks all the SQL injection and other common attacks. Okay, so I'm going to do OWASP ZAP check. So I've heard this described as a pen test. It's not really a pen test. It's more toyish like that. And it didn't stop my last customer who said he ran it regularly from not noticing that none of his web API controllers had any kind of authentication on them, and they were all free to air. But as with all the other tools that I've shown you this evening, it provides useful information. So don't run this and say, yeah, it's been pen tested. Certainly not. A pen test is a professional activity. They charge a lot of money for it, and you should do that as well. OWASP ZAP is just another tool in your arsenal to pull as much of that security left as you can. So you can check HTTP headers, it can do fuzzing, look for directory traversal vulnerabilities, do port scanning, attack WebSockets, look for standard cross-site request forgery attacks, information disclosure, HSTS not set, look at cookie settings, all that kind of stuff. So lots and lots of different things. So if you go to the marketplace, it'll go, oh, you need to add in something like a step like this. So this is pretty much copied verbatim from the marketplace. It only runs on Ubuntu because it's written in Java. So you need you need a Linux VM to run it. So this performs the test, and it's saying attack this URL and use a targeted scan over port 443. And this is my context. I'll go on later on about what a context is. So this bash script is a hideous piece of boilerplate copied verbatim from the marketplace. The OWASP ZAP output and convert it into something you can read, well, an XML file here. So this generates the NUnit type for ZAP report, and then this publishes the results. Okay, so that is literally copy and pasting. So every time I check in now, I do a security test, it deploys the application to my environment, and it does an OAuth ZAP scan against it. So ZAP looks like this. So I've got a security, a context. So a context kind of defines my application. So it tells me what to include. So it's going to include everything that starts with HTTPS/security essentials. I can exclude, for instance, CDNs or graphics I've nicked from other websites or links to other websites. So when it spiders the website, it doesn't go down those paths because it knows that it's not part of my application. I can give it some clues as to what to check for. So I can say, don't bother looking for SQL injection related to Microsoft Access because we don't have any. It's Microsoft SQL Server, and then there's JavaScript. It's based on Windows, and that kind of thing. So it can skip over a whole load of investigation for vulnerabilities. I can teach it how to authenticate. I can say, this is your login URL. This is how to post to it to log in. These are the users. So I've got an admin user and a normal user. You can use the application can use those to then log into the application so it can get past that login page and start probing for vulnerabilities beyond the login page. And it tells you what kind of session management it does. So if you spider a website, so I can just go click attack, or I can just click on this website and spider the website. Spidering means just following all the links, getting a footprint of the website. And then once I've spidered it, I know all the web pages, I can use an active scan to attack it. The other thing worth mentioning is it's got lots of add-ins. So these are all the add-ins it can use. So there's the directory listing, fuzzing, libraries, heads-up display, port scanner. So all of these are constantly updated all the time. So this all produces a report, which looks like this, and it's saying that I've found 5 medium-level vulnerabilities, 7 low-level vulnerabilities, and 6 things you should know about. So first up, it's telling me that my proxy, that means Cloudflare, is giving me some information disclosure that I should probably do something about. My CSP is content security policy. My style source includes unsafe inline. Yeah, it's that blasted data grid again. The data grid needs unsafe inline to work, but it presents a security vulnerability and potential cross-site scripting if an attacker can inject code into my site. Yeah, again, scripts of unsafe inline, that's the data grid. I need to do something about that. So enough about CP. So I've got some cookies without same site attribute. That's going to be important in Chrome. So it might stop some functionality of my website in the future. This cookie is being released without our secure flag. Oh, yeah, but it's the AR Affinity one, so that's the one that Azure sends down. But I can switch that off and convert it. So as with any of these tools, none of them are a silver bullet. They all provide different perspectives. I was surprised working on a allegedly secure code base, just how much I was learning with each step. Now, there is a Venn diagram and there is some crossover between them, but every different tool was giving me a different security perspective and teaching me more about security as I was going along. Cookie selected. Okay, lots of stuff. So we can have security acceptance tests. So I've got one that validates anti-throttling work. So this, for instance, like you can only make a certain number of requests to the login page per minute, so that prevents credential stuffing attacks. You can assert that the HTTP headers are not doing information disclosure and have the correct content security policy set. The account process, registration, password reset, account process enforced. Yeah, a user registered with a POEM password will be shown the warning. So, for instance, this is my security acceptance test. All of these are done using Selenium, obviously, so this requires a deployed website. The application will prevent a brute force login attempt. I navigate to the website, I click on the login link, I enter these login data. Obviously, this is my first guess at the password. It was wrong. I log in, I try and log in again, I tried and log in again. And then after a certain number of attempts, the web page should then show you've requested this resource too many times in the last 30 seconds. So I'm asserting that my credential stuffing prevention is working and will block an attacker or severely slow them down. So that's an example of an acceptance test you can have. Okay, so we've designed the code, we've checked it in, we've got some binaries that have been built via continuous integration, we've deployed the website, and now we've then promoted it into production. So once it's in production, we're going to look at availability monitoring, and continuous vulnerability scans. So the ARM template defines an alert. Basically, it's pinging the website. So it's saying, are you up, are you up, are you up, every 5 minutes, and it will alert you if it goes down. So that's the availability part of confidentiality, integrity, and availability. So it's pinging it from 2 different websites, and it will alert some admin users if the site goes down. You've got something called Azure Security Center. So this is the Center for Security Alerts that runs across all of your resource groups in your Azure subscription. And it gives you some recommendations, and it breaks it down by the different resource you got deployed. So the Security Center helps with securing sets transparent data encryption. It tells you if it's not on. It tells you if you haven't put auditing on, or it's not on for long enough. Diagnostic logs are enabled, so who accessed the key vault, when, and what did they access. Tells you if course is too permissive, whether you haven't enabled encryption for either your blob storage or your SQL Server. So this is a lot, it's similar stuff to AZSK and what that was doing, but it's from a different perspective. Well, there was different sets of rules. It's 2 teams that wrote these different sets of rules, so you always get a different perspective. By this time, it's in production, so you know the time to catch it was really as early as possible. So I can tell you if you need to enable 2-factor authentication, and whether the storage access should be firewalled. So if you've got VMs, then there's a security agent that needs to be deployed on that, and then linked through to your subscription. Okay, so this is the one I usually go to. Is saying recommendations. I've got set of 5 high severity recommendations, 2 medium, and 1 low. If I'm going for PCI DSS, it gives me a score here. So if you want the compliance aspect, you need to move from the basic to the standard package subscription, which costs you a certain amount each month. So people are going to go, well, okay, so not all of PCI DSS is about the platform. That's right. So it'll give you a textual description of anything that's not platform related. But the thing that is platform related will tell you whether you're complying with that and what you need to do if you're not. So if I go to the recommendations, it's telling me that I need to remediate vulnerabilities. I've got database vulnerability I need to be aware of. Here, I've got too many owners. Well, I've got not enough owners assigned to my subscription. So this happened to us where the guy who'd set up the Azure subscription, he sold his phone, and we'd all set up 2-factor authentication, so we could no longer get into the site, which is a pretty major problem when you need to get access to it. And it took Microsoft weeks to sort that out and get us a so having a second owner will help you there. Classifying sensitive data, so that's in SQL Azure. So once you've classified data as sensitive, so for instance on the GDPR, usernames, names, addresses, all that kind of stuff, you can then log who accessed that data and when. Data encryption, that kind of stuff. So it gives you a score. It tells you what you need to do and what's more important than other. So again, this is feeding back security back into your process. It does database vulnerability scans. So I get an email like this every week that says my database is failing 5 checks, which is quite useful because we're deploying stuff into live all the time. So it's checking. So this helps you on again, classification of sensitive data, correct setting of database owners, checking your firewall configured correctly, guest user disabled, transparent data encryption is enabled, all that kind of stuff. So things we didn't cover tonight, which are quite important. One thing that's really important is 2-factor authentication. That closes down impersonation attacks by about 80%. It's really important to stop people getting access to your Azure subscription, or AWS, for instance. Your CI/CD pipeline is the heart of security, enforces the rules. So locking down who has access to that and potentially bypassing that is quite important. Code reviews, peer reviews are another way of spotting security checks, security flaws before they get into production. And pen tests. Pen tests should still occur. They're really important. You've got some professionals there with a huge amount of knowledge. But with each vulnerability they find, you need to be feeding that back into your process. You need to be saying, could I have spotted that at the IDE stage? Could I have spotted that at static code analysis stage? Could I have spotted that via a new dynamic test? So it's always feeding back in to improve your process. Secure defaults mean fewer security defects. The source code I've given you gives you a lot of those secure defaults. We've also got an automated deployment pipeline and security pill pipeline that pushes it out, which means that if you do get any security defects, they can be fixed faster. In terms of tooling, we're looking at a lot of tooling today. We've done a bit of lightweight threat modeling. If you're looking at a new kind of resource you've never seen before, it can tell you via Stride what kind of threats and risks you're opening yourself to. IDE checks can tell you important information as soon as you type some code that you're introducing a security vulnerability. Pull left security identifies security defects early. You're not waiting for that pen test at sprint 7 before you find out there's something wrong with the code, or you're finding as much as you can as early as possible. We looked at a number of static analysis tools. FXCOP has a great number of rules that identify security vulnerabilities. We've pushed up code to SonarCloud, which does a whole suite of analysis on your code and then gives you really detailed instructions on how to fix it. We've analyzed the platform. We've analyzed our ARM template that produces the Azure resources. We've looked at the Azure resources themselves via AZSK and said, you know, the people who've been working on security have said, this is good practice. How does my setup compare with good practice? We've looked at a suite of packages that come under NCSA. Here's a credential scanner to make sure we haven't checked in passwords or certificates or hashes or anything that's used as a secure code. We looked at TypeScript security via TSLint. So now we've looked at software component analysis. We looked at OWASP dependency check and all the checks that that's doing. How we identify risks associated with packages that we rely on. And the same with White Source Vault, which also looks at license vulnerabilities. Binskin looks at how securely was the application you're relying on compiled. We then deploy the application and we do dynamic testing via OWASP ZAP. Mini pen test does a whole suite of tests and provides important security information. And then we do security acceptance tests. So we do unit tests and acceptance tests. Does it have the right headers? Is our cross-site request vulnerability checked for? Is our credential stuffing protection working? So when it's in production, we're looking at, is the application that is available? What is Azure Security Center feeding back to us about our security profile? What do we need to improve on? The continuous vulnerability scans that run on our databases on a weekly basis, what is that telling us about how we need to improve security? And we've seen that although there is some crossover between all of the tools, each one is giving us more information about our security at each stage and earlier. So just a few resources. A lot of the process that I talk about is based on this book, DevOps Sec. Securing Software Through Continuous Delivery by Jim Bird is an excellent book, and it really steps out each of those stages and breaks it down for you and tells you about tooling. It's mostly from the open source perspective, so you'll hear about Chef Puppet a lot more about rather than the Microsoft approach, but it gives you a really good perspective on how to approach DevSecOps. So there's a couple of good Pluralsight courses I could recommend that cover some of the tools that I've mentioned this evening. There is the excellent Azure Security Best Practices. This is a very readable online document about how you should secure Azure. And I've just finished reading the Unicorn project, which shows you how not to do security and how to do security in a continuous deployment organization. And it's a really, really good read. I'd thoroughly recommend that. If you're lacking something to read on holiday, it's a good read. Okay, are there any questions?
So I've got a few, John, if you don't mind me shooting off the questions.
No.
Great presentation, by the way. I really enjoyed that.
Thank you.
The OWASP, would you run that against your QA environment, or for instance, does it submit forms?
Okay, so OWASP is destructive. So OWASP will destroy your data and pound stuff into it that you probably don't want to it. So whatever environment you need to run it against, you should run it on a disposable environment.
Great.
So that's why I run it against my integration environment, because at the end of the Azure pipeline script, I tear it down. So I destroy all the data and then build it back up with the next deployment. I appreciate that was a lot of information. It's not meant to be absorbed all in one go. That's why you've got GitHub, and then there's a slide share, all the slides on slide share as well. So you can go away and you can look in your own leisure. There's also, you can get me on Twitter as well.
There's a lot of tools there as well. You've gone through a lot of examples. So with SonarCloud as well, I think it's worth pointing out, I've used SonarCloud, and there's also a Visual Studio extension called SonarLint, which will hook up, and it allows you to do the checks inside Visual Studio.
Oh, cool.
So, and I think for anyone else wanting to try it out as well, SonarCloud is free also, up to a certain amount of lines of code. I think it's like 60,000 lines of code. I think it's free up to for checks. With all of the PowerShell deployments as well that you've done, are they custom PowerShell scripts, or did you? Because you've got are they scripts that you can find online, or are they custom ones that you've built yourself?
These are things I've come up with myself. So yeah, you got a pre-deploy step. So it'll take you know, some secrets that are in Azure DevOps and configure Cloudflare. This is because I use Cloudflare rather than the WAF that's inside Azure, because I think it's really good, the Cloudflare one. So yeah, that's all REST calls. This sets up the secrets in the key vault and configures security on the blob storage. Yeah, it's all Cloudflare. So this configures Cloudflare. So this is all like the DNS entries. So if I deploy a new subdomain on the site, it'll configure the subdomain. And then I can have the subdomain for integration, for QA, for stage and live. And then post deploy. So this gets outputs from the ARM template, like secrets that are generated that you can't specify, because some of the Azure assets you can't specify, like the connection string that you use. You just have to get out the ARM template, and then it locks it down. So this one is, so we had a pen test. Well, how do you know that Azure PaaS is updated by Azure? So the only way we could do it was by polling the Azure Kudu tools, and then it gives you like this string that says what version of the platform it's on. So that was purely to respond to a pen test that we had. So then you need to get all of the IP address restrictions, which we got in the previous. The IP addresses of Cloudflare, which is a whole suite and which is dynamic and may change. So then you lock down the app service to only talk to Cloudflare and won't accept requests anywhere else. So, I mean, it's all there for stealing. There's oh, and this just, you know, after you've deployed it, it wakes the site up. So, you know, it's pretty standard stuff, I'd say. There's a lot of work gone into it.